Hello everyone, my name is Wandani Putri Siregar. In this video, I will present the result of my critical journal review in the engineering English course. No need to be laggy, let's get the main point of the discussion.
Slick back.
No, slick back.
That's what I said. Slick back.
No, nigga, I'm a pimp named Slick back. Pimp named Slick back. Pimp named
Slick back.
Nigga, are you deaf? I'm a pimp named Slick.
Okay. Presentation of critical journal review result in the title Analysis of Influence of Winding Short Circuit Fault on Electric Field Distribution in Power Transformer. Journal Identity. Author Gang Liu, Yan Bao, Ding Jianwen, Ting Na Feng, Jian Qiaoma, and Tianming Chai. Title Analysis of Influence of Winding Short Circuit Fault on Electric Field Distribution in the Power Transformer. Abstract. As the key electrical equipment of power system, the internal fault at transformer may affect the safe operation of transformer. Among them, the winding short circuit fault is one of the most important factors affecting insulation deterioration of the transformer. Long-term operation might cause partial discharge in the transformer. In safe case, it might lead to insulation breakdown or surface discharge. Therefore, it is of great significance to study the variation of electrical field strength near the winding short circuit fault of transformer. Research aims to investigate the distribution of electrical field in a power transformer under different fault conditions. 2. Do analysis the impact of winding short circuit fault on the electrical field distribution in the transformer. And 3. To identify potential area of weakness or vulnerability in power transformer that might be prone to winding short circuit fault. And method research. Especially, the research uses an electromagnetic field simulation software called Ennis Maxwell to simulate the electrical field distribution in a transformer winding under short circuit fault condition. They then compared the simulation result to experimental result obtained from a physical transformer under the same fault condition. Next, introduction. The power transformer is an important equipment of the power system, and its safe and stable operation is of great significance to the power system. When the transformer winding is short circuit, the short circuit current and reaches 10 times more current than the red current, which seriously damages the insulation performance of the transformer insulation material. The may causing insulation failure. Studies have shown that transformer winding interturn short circuit fault have the highest incidence. According to the statistics, winding interturn short circuit fault account for approximately 2 of transformer winding fault. Simulation model. In the homogeneous linear and homogeneous medium of electrostatic field, the relationship between potential and charge density can be calculated by Poisson equation and Laplace equation. And analysis. After carrying out calculation, the distribution program of the electric field strength in the power transformer is obtained. because the structure of the transformer is symmetrical on the left and right side. The nephogram of the distribution of the electric field strength on the left half of the middle path of the transformer in the intercept, and the nephogram of the distribution of the electric field strength at the head end of the transformer winding. This is literature review. Next, operational dependent variable. An operational dependent variable is a variable that is measured of observed in a scientific study to determine the effect of an independent variable on it. In other words, the dependent variable is the outcome or response variable that is being studied. The article influence of winding short circuit fault on electrical field distribution in power transformer. The dependent variable called the electrical field distribution in the power transformer under different fault conditions. This is relevant because the study seeks to determine how the winding short circuit fault affects electrical field distribution in power transformer. So the electric field distribution in the outcome variable ways and tools of measuring dependent variable. In the case of the electric field distribution in a power transformer under short circuit fault condition, the research in influence of winding short circuit fault on electrical field distribution in power transformer used a combination of simulation and experimental method to measure the dependent variable. Simulation tools such as ANC as Maxwell were used to model the electric field distribution within the transformer winding under different fault conditions. The researchers ensured that the modeling assumptions were based on the physical properties of the material being studied. An operational definition of independent variable. In the article, Influence of Winding Short Circuit Fault on Electrical Field Distribution in Power Transformer, the independent variable is the winding short circuit fault condition. The research manipulates this independent variable to see how it affects the independent variable, which in this case was the electric field distribution in the power transformer. An operational definition of an independent variable is a specific and measurable definition of the variable that is relevant to the research question. In this case, the research used a specific type of winding short circuit fault condition that was designed to simulate common types of fault that can occur in power transformer. Specific fault conditions include turning to turn, short circuit fault, pass to pass, short circuit fault, X. And then research result. In influence of winding short circuit fault on electrical field distribution in power transformer, conduct a series of simulation and experiment to investigate the impact of winding short circuit fault on electrical field distribution in power transformer. The result of the study showed the different types of fault can cause significant fluctuation in the electrical field distribution, with the magnitude and extent of this fluctuation depending on the type and location. Next, research trends. One of the strengths of study influence of winding short-circuit fall on electrical field distribution in power transformer. In the combination of simulation and experiment, the research used numerical simulation and laboratory experiment to investigate the impact of comprehensive approach allow for a more accurate understanding of the phenomenon of interest and improve the generalizability of the result. Another strength of the study in the inclusion of multiple fall conditions and their realistic simulation. The research includes various types of fall that are commonly observed in partiality of the research, contributing to the development of more effective diagnostic approach. Furthermore, the result of the study provided valuable insight into the magnitude and extent of electric field fluctuation that can occur during short-circuit fall in power transformer. This finding can support future research aimed at improving the diagnosis and prevention of fall in power transformer. And next, research weakness. One of the potential weaknesses of the study influence of winding short-circuit fall on electrical field distribution in power transformer is its scope. The study focused solely on the impact of winding short-circuit fall and electric field distribution in power transformer. While this is an essential area of study, it may not capture all the factors that contribute to the failure of power transformer or their diagnosis. Another potential weakness is related to the experimental setup. The research used a laboratory experiment with limited number of samples, which may not accurately reflect the behavior of real-world power transformer. Additionally, the simulation may have some assumption that do not adequately represent the real-world condition, even though geared toward a realistic system. Okay, I end the video here. If there are any mistake in my word, I apologize. Thank you.